Welcome to another episode of Tri-State Supply on Tap. This next episode, we're going to cover drive installation considerations. And to make it more palatable, we're going to do it in 3 episodes. So if you want to just jump back to a certain one, it'll be easier to do so. The one thing I can tell you, a lot of times when somebody puts in a VFD, they just look at the VFD and they don't look at everything for the installation. And today, with all the supply chain shortages, you should be looking at the whole picture to make sure that your installation is going to hold up, because getting another one is not always easy to do. So with that said, let's go on to episode 1. Okay, this episode 1 of VFD drive installation considerations, we're going to talk about the input side. And a lot of people do not go back and look at this when you ask them what your transformer wiring is, what size it is. A lot of people don't know that, but it's something you should go back and consider. We're going to go over the grounding recommendations and the different transformer grounding schemes. We're going to look at the size of your incoming transformer, proper input protection. And this is all, again, can be referenced from the PWM installation guide that Allen Bradley provides on their literature library. Here's a typical installation. We have our transformer, which here is a Y neutral ground. You got your drive panel with your drive, and you got your motor and the cabling. Now, the one thing we want to try to do is get everything on this ground plane to be the same potential, and also have a path back to the drive, because that's the source of any of your noise that's going to be generated. It's going to want to get back to the source, and we want it to get back to the drive the shortest distance path it can. But in this typical installation, a lot of times you're going to run a conduit, okay? And conduit touches ground in many points, especially where you're strapping it down. And conduit, being a metal substance and thin, high frequency noise that the PWM carrier frequency generates on the drive is going to allow it to conduct onto this conduit. And if you're not careful, it could actually find a better path back to the drive through the ground plane and back this way. And that's what we're trying to avoid. This ground, which is recommended to be brought back straight to the drive, to the PE power section of the incoming side or output side of the drive. That will help eliminate some of this. But again, because of the high frequency switching noise, you want to consider a shielded cable, which we'll talk about in episode 3. So we go back to our transformer. There's several different configurations. Here are some of the more common ones. This is the one that the drive manufacturers recommend, a solidly grounded Y. Then you have your high resistance or resistant ground, which puts a resistor on that neutral, which is done a lot of times to reduce your ground fault currents. for safety precautions. Then you can have a delta corner ground or center tap ground, or an ungrounded system altogether. We're going to be concentrating on these episodes on the 750 drive family, but the PWM installation guide covers the various drives Allen Bradley offers. And they'll continue to update that as they release new drives. So if we look at the 750 chart, 480 volt in the PWM guide, we go to a 20 horsepower drive here. We look, it's 750 kVA maximum size that we want before we definitely recommend adding an input reactance in front of the drive. Now that could be a reactor, could be adding another drive isolation transformer, or if you had a harmonic filter, it has a built-in reactor as well. So that's some reasons. Another reason, just for cheap insurance of putting a reactor in front of the drive, is it helps avoid protection to the front end of the drive on spikes for maybe nuisance over voltage trips, or for sags especially, because when your voltage sags, you put stress on your rectifier front end of the drive. So that could help prolong the life of your drive as well. So not a bad practice to do it. But if you're not, if it's over 750, it's highly recommended by Allen Bradley to do so. Then we have our technical data sheet for the 750, which is going to be where you're going to go to find out what size fusing or circuit breaker I might need. Again, we're looking at a 20 horsepower drive. It's 35 amp minimum on like a class J type fuse, 60 amp maximum. Now, if you don't have a time delay fuse or using a circuit breaker, you can go up to a maximum of 100. If you do have an ungrounded or a resistive ground of any type system, it is to meet UL, it is recommended to add external surge protection to your panel. And this is because we're going to be in the next episode, depending on your transformer design that you're supplying to the facility for the drive, you're going to be eliminating that MOV in the drive. So external protection is required for UL. Again, this can all be referenced in the PWM installation guide that it can be found on the Rockwell Literature Library at www.ab.com. And that concludes episode 1.